Here are some highlights of the practical uses for the growing market segment of USB-based RF modules. The devices are simple and compact, yet very powerful tools for performing affordable RF tests. They operate as peripherals connected to a standard laptop or PC and can be controlled via a simple graphical user interface with a mouse or touchscreen. They can also be integrated into more sophisticated automated test environments. First, we'll show some of their basic performance metrics to give you a flavor of their capabilities. Then we'll describe some of the creative ways these devices are being used to solve everyday RF engineering problems. The Telemakus USB device family is based on a housing that is slightly larger than a common flash drive. This means that the devices are truly portable. Every device is designed to perform a particular RF function such as power sensor, attenuator, RF source, amplifier, phase shifter, and so on. They are powered by the USB bus and they contain all the necessary line regulation and filtering to ensure that the RF remains isolated from the bus. Each device contains its own half-gig flash drive memory that contains all the software to drive it from the PC, as well as other information such as cal tables, datasheets, factory data, and so on. So, the device in your hand has everything needed to connect it to any PC and begin using it. Each device has its own graphical user interface that is simple, intuitive, and gives the engineer, technician, or student an immediate means of utilizing its basic RF function. For power users and ATE engineers, an applications programming interface allows the device to be controlled programmatically in a number of software languages. These devices have been designed to be affordable for every engineer, student, or faculty member. One progressive university is developing a study program with students using these instruments in their laboratory coursework. They will provide incoming students with a set of these RF modules for experiments. Then the students will have their own personal test equipment to take with them into the workplace after graduation. The Telemakus product family includes a wide variety of RF functions covering many of the popular RF frequency bands. The most basic instrument is the TED 6000-50 RF power sensor that covers the frequency range from 50 MHz to 6 GHz. Power correction is provided in both frequency and power over the full dynamic range of the sensor. Telemakus also has a line of signal sources that extend into the millimeter range. The TEG 4000-1, for example, is a broadband synthesized source that operates from 35 MHz through 4 GHz with a frequency resolution of 1 kHz. The output power over the frequency range is typically plus 1 dBm, with spurious better than 75 dBc, and excellent phase noise specs. The newest product in the signal source lineup is the TEG 6800-10. Its frequency range is 54 MHz to 6.8 GHz with an output power exceeding plus 10 dBm over most of that range. The other offerings in the RF source lineup limit the bandwidth to an octave-wide range to provide both high power and better phase noise performance around popular signal bands such as 900 MHz and 2.5 GHz, as well as higher frequencies like 10 GHz and 26 GHz. Another popular item is the TEA 4000-7 RF attenuator. This is a broadband 100 MHz to 4 GHz active step attenuator which has a quarter dB step resolution over a 30 dB control range. These three devices together form the nucleus of a very potent set of RF test capabilities that rival the old-style scalar analyzer products that are still in use today. The product line is also populated with other devices that have a more specific purpose, such as vector modulators, phase shifters, amplifiers, and a frequency doubler. The A6000-15 frequency doubler is unique in that it has a built-in bypass feature that allows a fundamental signal to pass through unmultiplied with a matched gain. So pairing this device with the TEG4000-1 RF source gives you a 200 MHz to 8 GHz source capability. Of course, no RF functional library would be complete without a set of RF switches. The Telemakus switches are active RF SPDT switch devices with some unique features. The TES3000-60 is a high isolation device with 60 dB isolation at 3 GHz and typically better than 80 dB isolation below 1 GHz. It has internal terminations and the ability to have all three ports simultaneously isolated from each other. The other switch devices have better than 30 nanosecond switching times and come with the ability to function as RF pulse modulators. This pulse modulation capability is a hardware function and allows for precise control of RF pulse widths down to 125 nanoseconds with periods as long as 8 seconds with any duty cycle in between. The Telemakus product line includes a set of USB accessories that make it convenient to combine multiple devices into more complex systems. Both the 4 and 7-port USB hubs are externally powered and designed to provide the maximum current loads available over the USB bus. The 7-port hub also has the unique feature that the pitch between USB ports exactly fits cascaded RF devices to minimize the need for interconnecting RF hardware. Telemakus has also recently introduced an attenuator specifically designed for testing the latest MIMO Wi-Fi devices. The A6000-95 is a solid-state attenuator in a rugged metal housing that has 95 dB range of attenuation and half dB steps and covers the frequency range of 100 MHz to 6 GHz. This device is the ideal choice to simulate RF channel losses and signal fading in a live production test environment. Its low cost makes it the component of choice for test engineers that need to emulate multi-channel RF paths for more complex 3G or 4G MIMO Wi-Fi test systems. It's a simple matter to connect multiple devices to a single PC controller using the USB bus and build a 3x3 or 4x4 multi-channel RF network using these devices. To make it even easier, the software to control this device is available in both Windows and Linux operating systems. Telemakus devices are easy to install and use. Installation begins as soon as the device is plugged into a PC for the first time. There's no special driver libraries to install or maintain. Everything the device needs is either located on the flash drive or is native to the PC. The only step the user needs to complete is to open up the flash drive and select whether the installation is for a 32-bit or 64-bit system. Once the application is installed, the user can launch the graphical user interface and immediately begin using the device. The GUIs all share a similar intuitive user interface similar to the one shown here for the TEG4000-1 signal generator. Simple radio buttons are used to turn RF power on and off and to select features such as carrier wave or swept frequency operation. Start and stop frequencies are entered using the keyboard, and the carrier wave frequency is set either by using the slider or typing in the value. Step arrows are provided for conveniently stepping through fixed values. The step size can either be one of the standard values on the radio buttons, or a custom value can be entered. The step size is also used during the sweep operation. These devices have the capability of being able to program their own power on state. So, for example, if you wanted to operate the device as a remote carrier wave source without having a PC connected, you could program it to power on at a specific frequency, and then plug it into any 5-volt USB power source, including a wall charger, or any number of other USB rechargeable battery products, and you'd have a high-quality, self-powered RF source. Another interesting aspect of the user interface is that because it's PC-based, it will load and run on many of the newer rack-style test instruments and oscilloscopes that are also PC-based. There are a number of salespeople traveling around the globe that use these Telemakus portable devices as part of their demonstration kit to provide, for example, a third source for mixer testing, or to drive an A to D converter, or perhaps to show off the capabilities of their spectrum analyzer. The application programming interface is a Microsoft .NET assembly, which basically means it's compatible with any code development tool that's designed to work with .NET objects. So, these devices can be controlled using languages like C++, C#, VB.NET, or from other environments such as LabVIEW, MATLAB, or even Keysight's VEE. The first step with these applications is always to create an instance of the device object by assigning it to the object class that has been created to support that device. Once that's done, you can then begin to make calls to the library. Make calls to the library functions to actually drive the device. The USB connection is controlled by a management routine that automatically handles hardware connects and disconnects without crashing the application or the PC. It also cleans up after itself when the application is closed, so the user is freed from having to learn about USB bus management. The number of devices that can be controlled at any given time is only limited by the number of USB connections allowed by Windows. That's 128 devices. A typical test application may use anywhere from 1 to 7 devices. The units ship with example files on how to utilize the API. The examples are very basic but give the user a place to start. One of the examples shown here is a virtual instrument file for a LabVIEW application that shows the user how to open the device connection, read back a power value, and then close down the connection. Of course, support is available for developers from Telemakus. Here are 3 popular application examples for these devices that can be implemented for under $1,500. First, you can model the channel fading of a mobile RF transmitter. Second, you can make a direct digitally synthesized time base with microhertz frequency resolution. Third, you can create a portable RF source capable of driving both the digital clock time base and providing a pure RF tone for testing A to D converters. There are many other applications as well. Life testing is a good example. No need to tie up your best and most expensive equipment when performing a burn-in function. We have customers that are using a variant of the RF pulse generator to test the AGC system of their radio by switching back and forth between programmable RF levels. Other customers are taking a similar approach to test their antenna diversity switches. And the best part of using Telemakus modules is that the equipment is all modular. You can set up one test today, then break it down and set up a different one tomorrow. Now, let's take a look at a scalar network analyzer. The TDDS-100 is a direct digital synthesizer RF source that is capable of generating pure RF tones and timing signals over the frequency range of 1 kHz to 100 MHz. The device can be adjusted to any frequency within that range to microhertz, that is, 10 to the minus 6 step resolution. It's the ideal choice to use as an external 10 MHz reference to synchronize multiple test instruments. It can also be used as a pure RF source for evaluating the linearity of A to D converters. The plot here, taken at 10 MHz, shows that the device has minus 104 dBc per hertz noise power at a 500 Hz offset from the carrier. This is an exceptional value. Companies that manufacture mobile devices often struggle with implementing test strategies that can emulate real-world application of their devices. In the real world, transmitted signals are often reflected from other nearby objects and create interference with the desired RF signal. That situation is depicted by the top diagram, which shows the desired signal in red transmitted from a fixed tower arriving at the mobile device along with two other reflected signals. The result of the interference is depicted in the second diagram. The desired signal will fade because it is partially canceled by the reflected signals. The mobility of the receiver also introduces a Doppler shift of the received signal. These highly complex effects can be modeled and recreated using the simple set of Telemakus components shown in the next diagram. The settings of the Telemakus components can be altered by simple test software written by the user to emulate the real-time effects of the interference fading and the Doppler shift. Most remarkable is that the total cost of these components is under $1,500. Let's demonstrate this simple system's capabilities. Here, two TA6000-7 attenuators, each having 31.5 dB of attenuation range, are connected in series with a TEP2000-6 phase shifter device. The USB ports of the devices are connected to the Telemakus TH-UB7 USB expansion hub, which is then connected to the USB port of the controlling PC. This system provides amplitude control of the RF signal from 0 to 60 dB and phase control from 0 to 360 degrees. Here is the real-time response of the vector network analyzer with the VNA set to 1800 MHz carrier wave and the Telemakus devices being driven by simple test software to implement the indicated device variations. The first demonstration shows changes in amplitude only. The second demonstration is phase changes only. And the third combines linear changes in amplitude with linear changes in phase. The fourth demonstration changes both amplitude and phase using a mathematical model that emulates the predicted fade behavior known as Rayleigh mobile fading. Rayleigh fading occurs when a mobile device is affected by multiple interference signals while it's in motion, similar to the diagram shown earlier. This demonstration is a real-world simulation of a mobile RF signal performed in a laboratory using less than $1,500 worth of Telemakus equipment. This video shows the test signal being attenuated by the Telemakus devices over a range from 0 to 60 dB and then back to 0 dB again. The upper display is a polar plot of the RF signal, which illustrates both the amplitude and phase of the signal. The lower plot shows only the amplitude of the signal, but in greater resolution than the polar display. It's important to recognize that only the amplitude is being changed, and the changes in amplitude produce little or no phase distortion of the RF signal. This demo shows several cycles of the RF signal being continuously varied in phase from 0 to 360 degrees. This effect is identical to the Doppler shift of the RF signal encountered by a slowly moving mobile device. In this phase shift example, it's important to point out that the Telemakus phase shifter introduces little or no amplitude distortion over its full range of operation. Here, the video shows the combination of amplitude and phase changes occurring in real time. The final video demonstrates a simulation of Rayleigh fading. In this demonstration, a single mobile device is moving through an environment that has 6 specific reflected signals interfering with its operation. The simulation software computes a resultant amplitude and phase of the 6 signals and then sets the Telemakus devices accordingly to represent that result. A Doppler shift is also calculated for each of the reflected signals and factored into the simulation. Note that as the velocity of the mobile device is varied, the rate of change of the rotating Doppler phase also changes. The fade rate of the amplitude and the end of the resulting signals also changes with the velocity of the mobile device. This real-world result was created using less than $1,500 of Telemakus equipment and some simple control software that took less than 1 day to write. The results are a remarkable testament to the flexibility of the products Telemakus has to offer to the RF test engineering community. If you'd like to find out more about these innovative products, you'll find us online at www.saelig.com. The Telemakus pages feature an interactive product guide, and there are some additional demonstration videos available. Your next RF test application will go faster, cost less, and provide more useful results when you use Telemakus devices.